My name is Hazim Gaber, and today we'll be talking about types of transmission circuits. We previously discussed ability to convert analog signals into digital signals. So remember, we were talking about the ability to transmit a signal along a wire. There's three methods of transmission. One we call it simplex. We're going to hear this term more. Simplex means one direction. We also have, so in this case, we also have half duplex. So that's both directions. But one direction at a time. So if this is the sender, this case in the simplex, receiver. So this dude, he can send a signal to the receiver. If the receiver wants to send something back, he can, but he's gotta wait some time until the sender is quiet. So now the sender's quiet, doesn't hear anything, he can send the signal back. We can't both send at the same time because then we have collisions. So if this guy's sending and this guy's sending, get a collision and nobody gets anything. And then we have full duplex, where both sides can send and receive at the same time. And how that works, it depends. There's a lot of ways, and we're gonna find out. But a phone line, for example, is with full duplex. So if we look at, we have an idea called asynchronous transmission. Which means that every time, which means we can send data without a regular time interval. So send the data here, send the data here, send the data here, send the data here. And then synchronous transmission. We're sending our data at regularly defined intervals. So in order for me to send a data asynchronously, I have to have a start signal and a stop signal. And the reason is this dude here, he's listening. He's not necessarily listening to my data line. So I gotta send him the start signal to be like, hey, wake up, some data's coming. Then he starts paying attention and he reads the data. And then I gotta tell him that's the end. Because he doesn't know how much data I'm sending. He just heard, hey, there's some data coming. Versus on synchronous transmission, the receiver knows, every second I'm gonna get some data. So every second he pays attention for a brief time, captures the data. So we don't have to tell him it's coming, he already knows. And in order for us to do that, though, we have to send a pulse, known as a clock pulse. And this keeps everybody synchronized. Because if you have a clock and I have a clock, even if our clocks are, pretty accurate, even if they were synchronized with the atomic clock, they're going to fall out of balance after a while. So we have to keep everybody in sync. And that way, we know, we start right here, not right here, listening for data. So when it comes to transmissions, synchronous is better. We can use asynchronous if we have a very slow speed and don't want to take the effort to put it together. So let's take a look at some of the technology that we've created. And one of them is called ISDN, which nobody cares about anymore. Also known as Integrated Services Digital Network. And the idea was, what if we could take a whole bunch of different types of data and run them on the same wire? So we have idea different data types. Oops. On the same line. So I get two 64 kilobit per second voice / data channels and one 16 kilobit per second signal. It's 100 kilobit per second channel. And we call this thing the basic rate ISDN for homes / small business. And then we also came up with our primary rate ISDN for large businesses, and it's basically the T1. So remember, it's 1.544 megabits per second. It's actually 23 B channels. That's 1.536 megabits per second, and one D channel for signals. So 24 channels total. And then, obviously, in Europe, we have ISDN that's 2.048 megabits per second, which is 30 B channels. and one D channel. And remember, each channel, no matter where, is still 64 kilobits per second. And then, after that, we came up with DSL. So the idea was, can you run data over phone lines? And they came up with a bunch of ideas, HDSL, or high. This is known as digital subscriber line. High bitrate DSL. And we also have ADSL, asymmetric and we have SDSL, which is symmetric. So the difference, as we said earlier, between these two is that one has a time modulation and the other one doesn't. So the high bitrate, which is misleading, can give us 1.544 or 2.048 megabits per second. And then ADSL can give us between 1.5 and 8 megabits per second down and 128 kilobits per second to 1 megabit per second up. And SDSL can give us 6 megabit per second. And then we came up with VDSL, which is very high bit rate DSL, which can give us up to 52 megabits per second over cable. Not very many people use it though, but we can do quite a high bit rate. Okay, so now we're going to keep going. This is probably a good place to stop.